Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 2-8, two variable inequalities. Let's begin. First things first, let's talk a little bit about review. Can you circle each inequality? Now remember, in order for something to be an inequality, it needs to be n equal, alright? So it can't be something that represents any form of equal sign. So this is going to be the less than symbol, therefore this is an inequality sign. We have another less than symbol right here, so this is also an inequality. And this is literally saying not equal, so again, it is going to be an unequal sign. And last but not least, this is an equal sign, so therefore we can mark this off. We know that that is going to be called an equation. All right. Now, complete each inequality with less than or greater than. -2 is going to be less than that positive 1. 0.05 is going to be less than 0.5. 8/6 is going to be less than that 16/6, because again, if the denominators are going to be the same, then we just have to pay attention to the numbers. We can actually kind of get rid of these denominators all at once, and we can say that 8 is in fact less than 16. Now we have the 2 2/5 is going to be what to 7/4? Well, we have 5 times 2 is 10. 10 plus 2 gives you 12. So this becomes 12 over that 5. And this is 7/4. So if we were to do a common denominator, we can multiply this side by 4, multiply this side by 5, giving you 20 as a common denominator between both of them. So you get 48 over 20. Has to be something to the 35 over that 20. So which one is it? Is it going to be less than or greater than? Well, in this case, 48 is going to be greater than that 35, so 2 2/5 is going to be greater than 7/4. Our vocab for today is going to be talking about boundaries. All right, so a boundary is the line that separates the coordinate plane into two half planes, one of which consists of the solutions of the inequality. Example, y equals 2x plus 1 is the boundary for y is less than or equal to 2x plus 4. Can you circle the inequalities that have a dashed boundary line and underline the inequalities that have a solid? Well, in order for us to be able to do this, we need to know what makes it dashed opposed to making it solid. All right, so if it's a dash, that means that we're going to include everything that's going up to the line, but we aren't actually going to touch that line. And if you don't remember what that looks like, that's going to be anything that involves a less than or greater than sign by itself. Remember, it's kind of like on that number line where you had the open circles. We're getting very, very close to that point, but it'll never actually touch that point, and therefore it was open. Whereas the solid, the filled in circle, or in this case, the solid boundary line, is going to be included, which means we will see the less than or equal to as well as the greater than or equal to. So if it's equal to, it's going to be that solid portion, and if it doesn't have the equal to, it will be dashed. So looking at this one, we're going to do the circling portion first. I know that we can circle the first because this is a less than symbol, and the last because it's a greater than symbol. And the two solid boundary lines will be underlined, so the two remaining in the middle, that 2y minus 3x is going to be less than or equal to 9. That is going to be a solid boundary line, again, because it has the equal to portion. And the last one, that 4y is going to be greater than or equal to x minus 1. That will also be a solid boundary line, again, because it has the equal to portion. Great work. Problem number 1, graphing a linear inequality. You do this pretty much like you would a normal graph. There's only a couple things that we have to make sure we do. So let's underline the correct word or words to complete each sentence. The boundary of the line of the graph is going to be solid or dashed. Well, as you can see, this y is going to be greater than or equal to that negative 2x plus 1 is going to be equal to portion. Therefore, it is going to be a solid line that we're going to be talking about. And then when we were to graph it, we need to make sure that we graph it like we normally would. So I'm going to take this and I'm going to act as though it's a y equals a negative 2x plus 1. And I'm going to put the y-intercept on the plane. and I'll put a point right there. And then I'm going to follow this slope. So if this is going to be -2, that's going to be really -2 over 1. So I'm going to go down 2, 1, 2, and to the right 1. So it's that rise over run. And then I'm going to follow through with that pattern throughout until I fall off the coordinate plane. And I'm going to also go backwards. Now to go backwards, you just do the opposite. So instead of going down 2 to the right 1, I'm going to go up 2 to the left 1. And you'll know that you're doing it right because it'll keep that nice straight line going. Now, like we said before, the boundary line is going to be solid. Again, solid because of the fact it has the equal to portion. So let's draw a solid line that cuts through everything. Now, the difference is, when we're talking about inequality, we're not holding all of our information strictly to this line. It can be everything after or before this line. So we have to use something called a test point. We have to decide which way we need to shade, because the side that we're shading is saying that no matter what x value we choose in the side that's shaded, will make the actual statement come true. So the test point that we usually will use will be a 0, 0. We can use this as long as our graph, our linear function that we're talking about, does not pass through the origin. In this case, this linear function does not. It's very easy to plug in, so let's plug in that 0, 0. Again, the x value will be 0 and the y value will be also 0. So I'm going to get the y value, which is 0, is going to be greater than or equal to a -2 times our 0, again, because that's what the x value says, and I'm going to add that to 1. So is 0 greater than or equal to, well, -2 times 0 is 0. 0 plus 1 is just going to be 1. So is 0 greater than or equal to 1? It's not. Right? So we know that we can't shade towards that 0, 0, so none of these points can be shaded in, but we can know now that we can just shade in everything above the line, because everything above the line will make sense. So just to make sure, if I were to choose the point right here, the x is 1 and the y is 0. If I were to choose this point and plug it in, let's just see if it makes sense. So if, again, the y is 0, it has to be less than or equal to a -2 times our 1 value, because that is our x that we're choosing. And I like to point out that this is a random point that is just in the shaded region. All right, so that is going to be 1 that we plug in. I'm then going to add 1 to it. Well, is 0 going to be less than or equal to a -2 plus 1? Well, that means is 0 greater than or equal to a -1? And in this case, it is. And therefore, we can shade in everything above, because all the points, again, above will work. So once again, the test point 0, 0 does not satisfy the inequality, and therefore the graph of the solution should be shaded above the boundary line. All right, last but not least, let's graph the inequality. It should look something similar to this. Let's see how I did. Nailed it. Perfect. Great work, everybody. Problem number 2, using a linear inequality. The sign shows the number of tickets needed for small or large rides at the fair. You would like to get on both types of rides. You can buy 60 tickets with $15. You decide to spend no more than $30 for tickets. What are the possible combinations of small and large rides you can take? Use a graph to find your answer. So part 11, we're going to circle the greatest number of tickets you can buy with $30. Well, what would be that case? So if we have small rides are 3 tickets, large rides are 5 tickets, how many tickets can we buy with $30? Well, if you buy 60 tickets for $15, that would mean that we can double that amount of tickets for the $30. So the total that we can get would be 60 times 2, which is going to be 120. And can you circle the symbol that represents no more than? Well, no more than means that we can't ever go above it, but we can actually involve it. So it is going to be an equal to portion. So I can get rid of the first 2 symbols. So now it's either going to be less than or equal to, or greater than or equal to. Well, again, no more than means it can't go above the 120 mark, and therefore it's going to be less than or equal to. Okay. The number of tickets for small rides plus the number of tickets for large rides is going to be no more than 120. So if we let x equal the number of tickets for small rides, then we must let y equal the tickets for long rides. So let's pay attention to how much each costs. If we know that a small ride costs 3 tickets and a large ride costs 5, the number next to the x value will be 3, because it's 3 tickets. And the number next to the y value will be 5, because again, costs 5 tickets. So we now have this brand new equation, 3x plus 5y is going to be less than or equal to that 120. So what does that look like on the graph? Well, remember what we have right here. We do need to graph it, but we said before that the y value is going to be represented based off of the large ride, or the number of large rides, and the x value is going to be the number of small rides. So let's figure out what we have to do to graph. If I had to graph something in standard form, I'm going to find its x and y intercept. In other words, I'm going to find where it hits on this line, on the y-axis, and I'm going to find where it hits on this line, the x-axis. So the first thing I'm going to do is I'm going to plug in a 0 for the x value, and it'll give me a y value. And I'm then going to plug in a 0 for the y value, so it gives me the x. So we get a 3 times 0 plus a 5y is going to be less than or equal to 120. And we'll also get the 3x plus 5 times 0, again, is going to be less than or equal to 120. This cancels out. 3 times 0 is just going to be 0, so we're going to be left with really a 5y is less than or equal to 120. If I wanted to get y by itself, I can then divide both sides by 5. You would get 120 divided by 5, which is 24. There you go. And then the same thing over here, only in this case, we're going to get rid of the 5 portion because that equals 0 anyways. And then we can divide everything by 3. When you divide everything by 3, you'll get that x has to be less than or equal to 40. All right, so if I were to realize these 2 points, I now know what the y is for the y-intercept. It's going to cross the y-axis at 24, so I'll put a point right here. I also know that it's going to cross the x-axis at the 40, because the x-intercept is going to be 40. And now I can just draw a line straight through all the way down. Well, now that I drew the line, and it is equal to, that's why it's a solid line, we do need to figure out which way to shade. So let's plug in a 0, 0. All right, so if I were to plug in a 0, 0, that would actually become very easy, right? Because 3 times 0 is just going to give you 0, and 5 times 0 is just, again, going to give you 0. So 0 plus 0 is going to be less than or equal to 120. Well, 0 is, in fact, less than or equal to that 120, and therefore, since it does work, we are going to shade downward towards that point 0, 0, because all of these points will make this to be true. We can't go above it. Therefore, we'll get a graph that looks similar to this. All right, so complete the sentence with the words below. Each word should be used only once. Combinations, shaded, and whole. All the points with whole number coordinates in the shaded region represent a possible combination of small and large numbers. Notice, it needs to be a whole number. And a lot of that's because you can't have a fraction of a ticket, right? When you purchase a ticket, we're purchasing the entire ticket. In other words, you have to pay attention to any point on the grid where you get that cross action will be a type of combinations that you could potentially get to that 120. Now, if it's a little bit lower, then you're not using all of your money, which is perfectly fine, but you will be able to figure out the number of large rides as well as the number of small rides. Problem number 3, graphing an absolute value inequality. Well, in order to do this, you still just have to graph a normal inequality sign. The difference is you have to figure out which way to shade, because shading is really the biggest difference between an inequality versus a standard equation. All right, and obviously you have to pay attention to the dashed or solid. In this case, it's going to be a solid, but we'll talk about that one a little bit later down the road. So what is the graph of y minus 4 is going to be greater than or equal to 2 times the absolute value of x minus 1? You need to solve the inequality for y. We need to get that y by itself. So if I had to get that y by itself, I'm going to make sure that I add that 4 to both sides. And I'll get something like y is going to equal 2 times the absolute value of x minus 1 plus 4. And notice they're going to use that equal to portion right here, because if you think of it like an equation, it's a-okay, because that's how you go about graphing it anyway. So now you can compare the boundary line to the inequality with the parent function. The boundary line is narrower. It shifted 1 unit to the right and also 4 units up. That little boundary line is going to be a little bit smaller. We do need to find a test point, so we need to plug that portion in. So we are going to get the point 1, 5. And if we were to plug 1, 5 in, we are going to get that we have a 5 for the y value, because again, our x and our y. Our 5 for the y value is going to be greater than or equal to 2 times the absolute value of the 1, which we plugged in for the x value, and I'll put parentheses around it. I'll even put parentheses around the 5 as well, minus the 1, again inside the absolute value, plus 4. And if we were to simplify this down, we get 5 is going to be greater than or equal to 2 times the absolute value of 0, plus 4. Absolute value of 0 is 0. 2 times 0 gets canceled out, and therefore we get 5 is going to be greater than or equal to 4. Well, 5 is in fact greater than or equal to 4, and therefore this is going to be considered a solution of the inequality. Now, before we do the shading portion, we do need to actually graph what this would look like. So if I were to graph this, I'm going to follow where the vertex tells me. The vertex comes again from the h and the k, which in this equation represents the positive 1 and that positive 4. So I'm going to go to 1 and I'm going to go up to 4. I'm going to put my point. That is my vertex. So after I do that, I just have to follow the slope, which happens to be 2. So I am going to be going up 2 to the right 1. Now, you do have to pay attention to the scale that's given. Notice the y values are increasing by 2, so me jumping up 2 is actually just going up 1 unit, what it looks like in the box. Right? And then I have to go to the 1 unit to the right based off of what the x's are going by, which means going up 2 and to the right 1 looks like I'm actually going up 1 over 1, but really follow through with the actual coordinate plane, what it's given. Now it's labeled, that's what it will look like. And we can do the same thing backwards because it is going to be symmetric, so every point on the right hand side is going to fold onto itself on the left hand side, and therefore we can plot our points. And we can just keep on following through with that pattern all the way up. Then you'll get that our absolute value equation will look like this. Now this is just the absolute value equation portion. Again, the solid line happened because it is in fact equal to. Alright, so now we have to figure out, are we shading above or below? Well, if I were to choose that 0.15, which is in fact the solution, I'm choosing a point that happens to be right here. And that point is actually going to be above the line. So if that is the case, then we are in fact going to shade above. So we can shade everything above. And let's see what this graph would actually look like. There you go. All right, problem number 4. Writing an inequality based on a graph. What inequality does the graph represent? Circle the parent function. Well, it is an absolute value. And I do see that it is being flipped upside down because the standard absolute value does go upwards. It makes more of a V, and this is more of like a partial to an A. Therefore, I know that we are going to be multiplying by some form of negative. So I'm going to circle the parent function. My parent function is the absolute value of x because of the fact that it is a V-like form. It's just being flipped upside down, which question number 19 says, circle the function that shows the reflection over the x-axis. Over the x-axis is a vertical reflection, and therefore it needs to be multiplied on the outside. Evidently, it's the only one that also is being multiplied by a negative in this problem. Therefore, that y equals negative times the absolute value of x is correct. And again, following through this graph, can you underline the correct word or words to complete each sentence? The graph is or is not stretched. Now, there are two different ways you can figure out whether or not this graph is or is not stretched. One, you can kind of see that as you go down 1 or half a unit from what you can see on the graph, it goes over half a unit as well, and that seems to be showing each and every time, and therefore since it's going down half into the right half, or since based off of what the graph is showing, it's really going down 1 to the right 1, I know that the slope is going to be 1, or also known as our A value is going to equal 1. You can also figure it out based off of the points given. So we're going to say that this point is -4, 3, and it's going to go down to another point down here, which is at the point -1, 0. If I were to plug both of those into the slope formula, that m is going to equal the y2 minus y1 all over x2 minus x1, you will get the slope is going to equal 1. And since the slope is 1, our a value is 1. And since our a value is 1, it will not be stretched. And since it's also 1, it's also not going to be considered compressed because we're not multiplying by a number that's greater than 1, not multiplying by a number that's in between 0 and 1. 21. Circle the function rule that completes the sentence. Transformations of a parent function are shown by... We have to do it based off of the original function, or the original form. The original form that we're going to be talking about will be the a times the absolute value of x minus h plus k. That will be the original form. Now, the reason you don't worry about the negative on the outside next to the a is because that a value very well could be negative. And if that a value is negative, that will be showing the reflection, but we don't have to worry about it always being negative. It will never always be negative. The other thing is the k needs to be positive and the h needs to be negative. The vertex of the function is negative 4, 3. Choose from the words left of, right of, up from, or down from to complete each description. So the negative 4 will be 4 units left of the y-axis because we're going to the left of the y-axis. We're going left on the x-axis, however, 4 units. We have 3 units going to be going up from the x-axis because it's going to be going up the y-axis, and therefore 4 units left of the x-axis is actually what they put, but the correct answer is the y-axis because we're going left of the y-axis. And it's going to be up from, they say, the y-axis, but again, we're moving up the y-axis, therefore we're going up from the x-axis is what the actual correct answer should be. A little bit of a typo. So again, it's going to be 4 units left of the y-axis and 3 units up from the x-axis. Use the answers to exercises 18 through 22 to write the function. Well, based off of what we can see, we are going to have some sort of reflection, so we know that we are going to have a negative times that absolute value sign. We are going to have an x, we are going to be going minus. In this case, we have to go to a negative 4, so we're going to go minus negative 4. And then we are going up 3, so we're going to be adding 3 at the outside. So x minus a negative 4 will give you a positive 4 plus that 3. So I would write y is equal to a negative times the x plus 4 plus 3. And that's what the equation of the absolute value will look like. However, this is an inequality, and therefore we need to pay attention to the fact that we're talking about all the points above the line, and on top of that, we're going to be talking about all the points above the line, and more importantly, we also know that this is not going to be an equal to portion because the line is dashed. So I know that I'm going to be talking about something with y is going to be greater than, because everything above the graph, that negative times the absolute value of x, and this is the absolute value, this is not a 1, the absolute value of x plus 4 plus 3. So you should get y is greater than a negative times the absolute value of x plus 4 plus 3. And we finally made it to the lesson check, guys. Everything is almost over. Let's get going, power through this one last question. So, is the ordered pair 3 over 4 is 0 a solution of 3x plus y is greater than 3? And can we explain? And we're going to underline the word or words or number of numbers to complete each sentence. So the value of 3x plus y when x is 3 over 4 and y equals 0 is what? Well, if x equals 3 over 4, I'm going to have 3 times the 3 over 4. And then I'm going to be adding that to our y value, which we said was 0, would be 0. So the full thing would be 3 times 3, because we just multiply straight across, and you get 9 over 4. So the answer for this one will be 9 over 4. Now, substituting in 3 over 4, 0 into this entire inequality results or does not result in a true inequality. Well, if this is what we got, if we got 9 over 4 when we simplified it out without setting it greater than 3, that means that if we can just write it as 9 over 4 must be greater than 3. And is that true or no? Well, in this case, I mean, it doesn't result in a true inequality, and therefore the ordered pair 3 over 4 is in fact not a solution to the 3x plus y is greater than 3. And that is it, everyone. Great work. Congratulations, we are finished. I hope you have a wonderful day. Stay out of trouble. Don't do anything stupid, and I'll see you guys in the next one.